Hello, Zalalam from 2620 is active. Today we will discuss on Java concurrency and multi-threading. But before that, if you are new to my channel, please subscribe. And if you like the video, like, comment and share. So concurrency and multi-threading in Java is one of the core concepts in implementing the Java programming language in Java coding. And before we discuss about multi-threading, what is a thread? We have to discuss what a thread is. So a thread is a control of execution and a control of execution of code executing a specific task, okay, within the same program. So when we think about multi-threading, we are talking about executing multiple tasks by a specific program. So for example, if we have multiple downloads in a browser that is managed in the same program with different threads. So that's what we mean by multi-threading. But when we think multi-threading, we will also have to think of multitasking. Okay, multitasking is an old concept which has been there in multi-core processors as well as single core processors. So this multitasking is managed by the operating system, and multitasking means multiple processes or multiple programs running at least parallelly. They look like running parallelly, but as you know, CPU execution is step by step, but the operating system manages the memory and CPU cycle for different programs, and the user conceives that these things are running parallelly. That's called multitasking. And the difference is each process in multitasking has got its own data. And if we want to have a communication between two processes, it's a costly one. When I say costly, it means it's costly in memory, in time, and in CPU cycles. And threads share data. They can act on the same data for different code execution, and this makes communication between threads very easier and with less costlier. And whenever we execute threads, we have to also think about the priorities of threads. The priority ranges from 1 to 10, and the main thread is usually with a priority of 5, and threads with higher priority will be given priority, and this will be managed by the process monitoring the execution of the threads. And when we say multi-threading, that means when we code, we have to create multiple threads, multiple execution of codes managed by different threads. So when we create threads, we can use either of the two methods. The first one is implementing the runnable interface. The runnable interface is part of the Java language library. So when we implement the runnable interface, the class that implements the runnable interface will be required to implement the run method of the runnable interface, override the run method, and this will be used as a thread, running a thread. The other is extending the thread class. The thread class is also part of the Java language library. So if we implement or extend this class, we can also create threads, or we can also initialize a new thread by initializing the thread class. And whenever we use multi-threading, we have to synchronize the threads. Okay, the communication should be synchronized, otherwise there will be a risk of deadlock. That means two threads depending on each other, but everyone should also release some of their own resources to get priority, so that makes a deadlock. And we can synchronize threads by using synchronized methods. That means we precede the method definition with the keyword synchronized, or we can use a synchronized statement block to synchronize statements in multi-threading implementing code. And when we implement multi-threading, we have to have a clear communication between threads so that there will not be blocking of activities or wasting of CPU time. So we communicate by the methods, thread methods, which are inherited from the object class, and the first one is wait. That means when a thread waits for another thread, that means it's expecting data from that thread to execute its activities within the waiting thread. So we make them wait until we get the data. And the other is notify method. This one, if a thread is waiting for another thread to forward data, then when the data is forwarded, the forwarding thread will have to notify the waiting thread so that the waiting thread will use the data without wasting CPU cycles or time. And we use notify all if there are multiple threads waiting for that specific thread to forward that data. Then once the data is released, that thread should notify all of the threads waiting for this. So notify all is for multiple threads. And when we use these methods also, we have to be cautious to avoid deadlock. Okay, deadlock occurs usually when two threads are depending on each other, and when one thread has to release the CPU cycles for the resources for another thread, and if the release depends on waiting to the other class, as well as the waiting also depends on releasing these resources within the same class. So this confusion might create deadlock. We will see in exercises how to avoid deadlocks. And whenever we implement threads, we have states of threads. So threads can be states can be accessed using the getState method of the thread class, and thread states can be new. We created a new thread, but it's not yet running, so that is a new one. And runnable, so the start method of a thread has been called, and the thread is potentially running. And the other is blocked, or a thread is blocked when it's trying to acquire an object lock. That means when it acquires unblock or the notification from the blocking thread, then resource is relinquished by the notifying thread, and the blocked thread can restart. So when the thread is blocked, that it's not executing or running, but it's waiting for resources to be relinquished by another thread. So the other is waiting thread. When a thread is waiting, it is waiting specific to a specific thread to be notified by the thread that is executing, and forwarding the communication to the waiting thread. There is also timed waiting. That means the thread is made to wait for a specified time, usually using the sleep method, and it's made sleep for specific times, a second or multiple seconds or nanoseconds, depending on the need. The thread is made to wait for a specific duration. The other is terminated. When the thread is terminated, then thread has exited running its code, or there is an uncaught exception which has resulted in halting and terminating of the thread. So once a thread is terminated, it has to be restarted with the start method. Otherwise it doesn't start by itself, by like the waiting thread or the blocked thread. Okay, that's it for this video. Thank you for watching. We will see exercises on threads in subsequent videos.